What if 99% of the data captured by our most advanced scientific instruments simply vanished into the void? For many space missions, that's not science fiction. It's the reality of the data bottleneck. Modern sensors on satellites and probes can gather terabytes of information a day, but the bandwidth to send it back to Earth is incredibly limited. This is where edge computing comes in. Instead of sending everything, we process the data right where it's collected, on the satellite itself. By making the instrument smarter, it can prioritize what's important, filtering out noise, corrupted data, or scientifically uninteresting information on the spot. To do this efficiently, these edge systems rely on a powerful tool, the compression codec. Codec is short for coder-decoder. Think of it like a master packer preparing for a long trip. The codec's job is to take a huge amount of data and pack it into the smallest possible package for transmission. There are two main approaches. First is lossless compression, which is like vacuum sealing clothes. Everything is squeezed smaller, but 100% of the original item is still there when unpacked. The second, more powerful method for science is lossy compression. This doesn't mean we lose the good stuff. It means we intelligently discard what we don't need. For a hyperspectral imager studying vegetation health, the codec might discard data from rooftops or roads, focusing only on the specific light spectra from plants. This is called scientifically lossless. The numbers might change slightly, but the scientific result remains identical, while the file size can be reduced by over 90%. So why is this so critical? Consider a mission to Mars. The connection is slow, and the window for transmission is short. An edge codec can allow the rover to analyze a rock sample, compress only the findings about key minerals, and send that tiny summary instead of the entire raw sensor reading. Or think of Earth observation. Satellites monitoring for natural disasters can generate petabytes of data, far too much to send down continuously. With an edge codec, the satellite can analyze images in real time, ignore billions of pixels of empty ocean, and only transmit high-resolution data of the developing hurricane. This enables faster alerts, saving lives and resources. It transforms the satellite from a passive camera into an active, intelligent watchdog. For deep space astronomy, edge compression allows telescopes to capture faint signals over days, filter out cosmic ray hits and noise, and transmit a clean, distilled discovery. We get more science per bit, drastically increasing the return on investment for these billion-dollar missions. So how is this achieved? The magic happens on specialized, low-power hardware like FPGAs, field programmable gate arrays. These chips are reprogrammable and incredibly efficient, allowing them to run complex compression algorithms using less power than a light bulb. Standards organizations, like the Consultative Committee for Space Data Systems, or CCSDS, develop the specific codecs used for these missions. For example, the CCSDS 123 standard is a multifaceted lossless compressor, while CCSDS 122 is used for lossy hyperspectral and multispectral data. This ensures that data compressed in space by a probe from one agency can be correctly decompressed and understood by scientists from another agency on Earth. It's this combination of clever algorithms and hyper-efficient hardware that breaks the cosmic data bottleneck wide open. The impact is revolutionary. Missions that were once impossible due to data constraints are now being designed. We can have higher resolution sensors, wider spectral ranges, and faster sampling rates, all because we know we can handle the data deluge at the source. The future is even more exciting with the integration of artificial intelligence. Imagine a codec that doesn't just compress, but understands the data. An AI-driven codec could autonomously identify an unexpected volcanic eruption on Jupiter's moon Io and decide to prioritize that data over its routine survey. Edge compression codecs are the unsung heroes of modern exploration. They are the crucial link that ensures the universe's greatest secrets don't get lost in transmission. They work silently at the frontier, intelligently packing discoveries for their long journey home, ensuring that when we look to the stars, we can see more clearly. than ever before.